Hello and welcome everyone. On the previous stream we played a lot with fibers, we learned the basics of it and did some asynchronous programming practice and implemented a few things. Right now I have some code that we wrote on the last stream, some code that I wrote somewhere in between, and we need to combine all things together and add asynchronous and interruptible evaluation to an REPL server. So by the end of today's stream, I hope we will get a basic REPL server, and it will be possible to connect it with arbitrary REPL client and do evaluation and interrupt this evaluation. That's it. My name is Andrew Tropin, and I do some guile, gigs, and scheme programming, and a lot of free and open source software development. So let's go to our topic. By the way, you can write down the questions in IRC chat, Tropin channel at Libera, or YouTube chat if you want. What we have right now? We have a very simple test that creates a thread and spawns an REPL server inside it. Also, it creates a socket which connects to the server, and we can send a simple operation, an REPL operation eval with code equal to some code. And here you can see the example of test case when I send a simple arithmetic expression and expect some value out of it. Let's execute it and see the results. You can see the log. An REPL server started on port blah blah blah. Simple eval arithmetics. The output log from the server, and you can see the test for 1 to 3 passed. And the same thing here. When we have a parenthesis which is not closed, let's update it. Code for evaluation. It's just a comment, it's not the actual code we evaluate for expected value here. Okay, let's restart it. Okay, we have two simple tests, one of which evaluates a correct arithmetic expression, another one evaluates expression without closing parentheses. It's written some time ago and the implementation far from perfect. But we will reuse parts of it and will integrate with the asynchronous code which we wrote for evaluation. By the way, you can find the source code for this project here in guile in REPL repository. And most interesting part that is actually an evaluation code is here in eval scm file, and the server stuff is here. So I will share a link here and here, so everyone can check out the code and look at it locally. But I have some changes that are not committed yet, but by the end of today I guess I will push all of them to the repository. Here is a simple refactoring where I moved use models to the model definition server. Let's comment all the stuff so we can see the diff of what changed since we started our stream. Server moved use models to model definition. Okay. I think this code should be moved to a different namespace. Drafts here. We can drop this line. Okay, it's some kind of hacks, I guess. Atomic box update implementation. It's not a perfect implementation, but should be okay. By the way, do I use it somewhere? Atomics box update session. Oh. By the way, do you hear the notifications from Mastodon? And do I need to mute them? I think so. Okay. I just checking that refactoring Atomics box update didn't break anything. Let's rerun the test. Okay, test still works, so I hope my changes doesn't affect anything. Pum pum pum. This is a recent change that I've done just a few hours ago, I guess, and it is nice one. Notify via condition when server is started. It allows to pass condition variable as argument to server start function and obtain and log on this condition variable until the server is actually started. We say that the server started when we starting listening the socket for incoming connections. And after we signal the condition, we just run a socket loop which creates a handlers for every incoming connection. But let's commit everything else. Clean up. Pum. Client input sessions. Not sure what does it mean. Okay, I think we can drop it. Interrupt op. Okay, it's some placeholder. Add interrupt op placeholder. By the way, people who didn't watch my previous stream or don't know what's happening here, there is an REPL protocol which defines quite simple asynchronous protocol using Ben code for encoding messages, which will be exchanged between client and server, which is actually almost language agnostic. So originally it created for Clojure, but we ported it to guile scheme and it works so far. You can read, it's relatively simple. You need to know only about Bencode, which is also a very simple protocol for exchanging data used in BitTorrents. And it has like a list of operations and a notion of session. When you connect to the server, you can send a clone operation, which will create a new session. You obtain the message returned by the server, and you can use this newly created session for sending future requests like eval, load file, interrupt, lookup, completion, or whatever. So almost all basic operations are described here, but we can actually introduce other, I guess. It should not be a problem. Okay, let's comment all other stuff. It doesn't seem like here's a lot of stuff. Minor tweaks. And we committed everything that we need. Oh, also let's commit the test. What if I comment out those two things? It will fail because this. Okay. Why I call test begin? Because it instantiates a test runner. Probably I don't need to call test begin exactly. Let me see. Surfy 64 testing test begin. What it does? Runner, test runner current, test runner create. I guess we can call test runner create instead of test begin. So something like this. Oops. It didn't work. Let's see. Test runner current. Maybe it should be something like this. Let's try it. Yes, that's right. But it counts asserts for every execution of test group. Not sure if it's what we want. Let's see how it works with test begin. With test begin, we doesn't have the result at the end of the execution. Okay. Basically, what can I do? I can just update a make file and add a wrapping test group here. Test group, integration tests, like this. Okay. It will be Surfy 64. Okay. The reason why I do so much magic here to run the tests is because I didn't find a good solution for a testing framework, so I wrote a few hacks to improve Surface 64 to make it possible to rerun tests, to make it possible to execute tests in the REPL, and so on. And here I use a test runner and few helpers from the model I've created, but it's not very well integrated yet. But after we finish guile and REPL, we will improve testing framework a little bit, and it will be much easier to use it, and it will be much enjoyable to program in Scheme, I guess. Okay, we have basic tests. We committed everything that we need, almost everything. Okay, let's commit it. Tests. Let's say use function instead of macro for setting up a server. One of the refactorings of the tests was introducing call with an REPL setup function instead of macros previously used here. The function basically do a very simple things. It creates a new thread with an REPL server. Inside it, it waits until the server started. When it started, it signals a condition variable. If you don't know what condition variable is, read the Fiber documentation and watch the previous stream. We already covered it in details here. After that, we create a client socket which connects to the same port where the server is listening, and it executes a procedure with one argument and passes client socket to this procedure as a first argument. So we can use the socket to issue requests to our REPL server. And here we basically does it. We call this function, passes a lambda which accepts one argument, and use the value provided by this setup function to issue requests to the server. Okay, we finished all our preparations. Now we can go and start refactoring. Let's focus on this function, which creates a server. Here we have some setup for the socket, and after socket is ready and we started listening it, we signal a condition that the server is started. After that, we execute a run fibers function which creates a scheduler, and we pass a thunk which starts handling incoming connections to the socket. And let's see what we have in socket loop. Okay, go to definition doesn't work here. Probably I didn't start a REPL, but it's not a big problem. Okay, the loop looks very simple. We have the loop itself, which destructures the result of accept call on the socket. And when we get client and other arguments, we spawn a new fiber, and inside this fiber we actually process the request. So let's go to the client loop. I wrote this code some time ago from the example provided in Fiber's manual. So I don't remember all the details, but overall it seems logical to me, at least at the moment. After that, we set some properties which are not very important for our tasks, today tasks. After that, we logs and notifies that new connection appeared, and here we use a log function, which is okay, but what I would like to have here, I would like to be able to disable logging if I want. So how can I achieve it? I can create a dynamic variable and parameterize it. It's one of the options, and it seems like a simplest option for me at the moment. So let's do it. Here we have a log function definition, which just wraps a format in some way. But what we will do, let's read the documentation for parameterize, and here we have an example of parameter. Define log make parameter converter. Okay, we don't need log simple. Simple log. Here we created a parameter log out of the simple log function. So later here in the code, if we use a log function, we need to wrap it in the parentheses, because now it's a parameter and we need to use parentheses. Actually, I would like to record a macro. I guess f3 log f4. Okay. It seems that we updated everything. Possibly wrong number of arguments to log. That's interesting. Don't know why it complains about it. Because everything seems to work fine. Let's try log something. It seems to work fine. Don't know why it complains. Let's see the documentation. Maybe Maybe we will find something here. Okay, it's very strange warning actually. It shouldn't be here. Because it's definitely a perfectly valid call for log function. And you can see that we have a new connection and input a response here. And I can do a trick to disable this logging by simply wrapping this thing in parameterize and the log equal to lambda, which does nothing. And here we don't have the logging anymore. So let's make an additional argument to the function. Log function will be simple log. And by default it will show all the stuff. And let's slightly update it. Instead of true, we will be using current error port here and current error port here. Nothing changed visually, but now instead of printing to stdout and possibly polluting stdout with our logs, we write it to error port. That's it. Let's commit this change. Server make log a parameter and use stdr for logs. Variable. Good. Let's go further. Our client loop. Here in the loop, if we find EOF object in our socket, we just notify that we are closing connection and close the port. Interesting comment here. Not sure what does it mean. But probably I wrote it myself, but I don't know right now what does it mean. But okay. Otherwise, if it's not end of file object, we just read from the client and transform the Ben-coded input to scheme value. And if we got an exception during decoding, we will return false as an input, and if we obtained false as an input, we will log that input is malformed. Okay, and after that we go and process a request. Actually, we don't need to process a request when the input is malformed, I guess, but let's see what we have in the process request. Process request. Okay, here is a moment that where we planned to do asynchronous processing of the messages, but not implemented yet, and it is the point that we will be improving today. Maybe we will also slightly update this function. I think we can do it here before spawning the thread. Oops. The client loop. Okay, the socket loop waits for connection. After that it accepts connection, and now we spawn a fiber which actually process all the requests coming from the client. That's very good. It's granular enough. Let's commit this thing. Move client pre-setup to socket loop. Okay, we got our connection, we got our input from the client. Now we need to process this input. Somewhere up the stack we should have created some shared variable containing all the sessions and all the information related to the session. So when we receive a clone operation, where the clone operation is? Here. We can easily register a session and do all the required stuff. For now, cloning the session, use a global variable called sessions, and it updates the value of this variable, which is not exactly right, not very clean solution. It's too much imperative using a global variables. Ideally, we need to store the sessions variable one per server created. So let's probably move it here to run an REPL server. Here we have a socket loop which accepts a hash table, but probably here we just can pass as sessions. Let's define sessions. For now it will be just an empty list, and here we will pass the sessions. Okay, socket loop. Store. For now it will be sessions. And here in the client loop it will also be sessions. After that, we ask to process a request with sessions variable provided, client and input. And let's see what process request here have: sessions, client and input. Why we use sessions as the first argument? Because it is a one variable per server and it doesn't differ between different clients, and client can be there can be many clients here. So it's more dynamic, I would say. This is one of the reasons I put it on the second place. Okay, and run operation. If input, run operations, log response, SM to Ben code. I don't remember why I splitted it into two separate functions. So probably to make a handling request asynchronous. We can call process request and just make another iteration of the loop and start waiting for new incoming message from the client. So it makes some sense. It still works. Let's spawn a new fiber here. And it still works. Very nice. We were able to spawn a fiber. Which is very good. But I'm not sure that it is a perfect setup here. Probably we need to spawn fiber. We need to spawn another loop which processes requests and push new incoming messages to it through the channel. Hello, Grigory. We of course have a sessions atom which we can reuse between those fibers and keep some state inside it, which can be also a good option. Let's see what we have here. Run operation accepts a list of operations and input, and based on op value, op field of the input, it calls get operation to obtain the function implementing this operation from this association list and executes this operation. Okay, let's see. We have clone OP, which uses sessions, but the sessions should be passed explicitly, I guess. Sessions. This way, we will need to pass sessions explicitly in every operation. Sessions. And probably this is a right thing. Almost all of the operations needed. Sessions. Okay, we did a small refactoring and broke something. Operation sessions input. Oh, okay. Sessions here and here. Let's see. Eval op. Okay, very good. Now let's write a test case. A test case which will do a clone operation, eval operation, and interrupt operation. And it will produce something for us. Okay. Test group. Simple interrupt workflow. Test equal clone session clone session should return us a new session, and we need to obtain the value of it. So define new session. Here somewhere in the drafts I have a simple code like this. Cider in REPL client. After that I try to get a response. This thing will just send op operation, clone operation. This thing will read the value provided by the server, and we need to extract a new session value out of it. Session ID. Session ID is what we are looking for. And test assert session ID. Oops. And REPL client. Very good. Clone session worked fine. But let's check that our test is correct. Let's go to the server implementation, clone operation, and let's comment it out. And it failed. You can see that if it doesn't return a new session, it fails. and now it goes fine. Let's comment out those tests because we don't need them at the moment, to make it a little easier to work with. Actually, in the proper implementation and in proper REPL driven development, we don't need to comment out tests. We just create another test and execute only a particular test. But for now it's a little bit too cumbersome, so I just comment out unnecessary tests and work on other tests. Okay, we obtained a session ID, and now with this session ID we can make another request. The request will be just evaluation request. Let's see what we have in our drafts. It will be something like this, but maybe even simpler. Session ID, operation eval, ID, blah blah blah, and REPL client. Yeah, looks right. And as a code, we will use a simple expression. Okay, just like this. Define. Okay. And now we need to obtain response because we have an asynchronous protocol. We will just need to call it, and now we need to extract the value. So ref, it will be under value, I guess, and test assert returned. Let's see if it works. It works. Value returned. That means we have a value key in our association list, but let's be a little more precise. Equal, we want it to be 5. Very good. But now we want to add a little bit more to this expression. Let's say we want to add a sleep here. Sleep for 5 seconds. And while it's sleeping, we want to interrupt the evaluation. Session ID, operation, interrupt. Let's see what we have in drafts. Okay, interrupt ID. Actually, I don't think we really need interrupt ID, but let's keep it. And as a result, we will get a different message. Definitely. Expected 5, obtained 0. Whoa, that's interesting. Very interesting. Let's see what we have here in the log. Response session value 0. Cool. The sleep 5 returned 0. Result. Okay, it evaluates for 5 seconds, as you can see, and it's not getting interrupted. And that's what we expect, because we didn't attach our correct implementation of evaluation with interruption. What we would like to get from it? Let's see. We need interrupt operation returns status interrupted. I would like to get status, and it should be interrupted, or maybe done interrupted. I don't remember. Something like this. Okay, works good. Now let's implement our tests. Let's make it a little faster. Actually, it will be much more faster when we make the processing asynchronous, and the result will be fired immediately. Let's see. For now it will take 1 second to evaluate this code, but when we implement interrupts it will become almost instant. Okay, clone OP works, completion OP doesn't matter, interrupt OP. This is a thing that we would like to make better. Let's commit our refactoring related to the sessions. And let's see how evaluation implemented at the moment. Eval OP. We have a very good thing here, which creates an evaluation thread that can be interrupted. Now we need to understand how to integrate already implemented evaluation mechanism which current state of operation processing. This thing creates a thread, creates a few more fibers which watches std out and std error of the thread, and they fires messages when std out appears, std error appears, and when thread finishes it sends one more message which contains the evaluation value of the thread. And also we have an interrupt condition which we can signal to interrupt the evaluation of this thread. So for now we have a sessions. Inside those sessions, let's see what we have. Let's see how it looks. Sessions. It looks very empty. It doesn't have to be this way. Definitely. Oh, maybe. Okay. Okay, I understood what is happening here. Let's see. The log apply format. Or not. You see this atomic box? It's actually a value of sessions, I guess. But why it comes so late? Okay, it printed somewhere else. It printed after input op interrupt. Log Okay, very good. We have a session with our session ID. Now let's see what we have inside input. We have the session ID, code, and ID. Very good. That means that we can extract session ID, is it? Okay, it's session. Okay, we extracted session ID. Now we need to do a quite big refactoring here. Here in every operation I return a data structure. And after I obtain this data structure, I send it to the socket. But I need to refactor it. I need to make every operation to send the result to the client on its own. So every operation handler will get not only sessions, but also a client as an input. And it will be handling the response itself. This is one of the options. Another option is to give it a channel. Which seems maybe a better option. Let's see. Oops. Channel, make channel. Okay, it works so far. Okay. I see the option here. We can make a loop. Inside the loop, we take value from the channel or the value of a condition. And if condition variable is signaled, we finishing our loop. If the channel value appeared, we send this value to the socket. Like this. Let loop. We have a channel. We pass this channel here. If input. Okay, I think that it should be a valid input already. So let's if when input process request, and here we always have a valid input, I guess. Maybe process send a message about malformed input. Not sure if we need to handle this case, but maybe let's keep it here for now. Okay, we always run an operation with session channel, list of operations, and input. Now each operation, instead of returning a value, can just send it to the channel. Here in the loop, we will make a choice operation, and it will be wait operation finished condition, finished channel finished. It becomes a lot of arguments. But it sounds reasonable. Okay, wait operation on finished. We need to wrap this operation. And if it finished const, otherwise get operation channel Okay. Get message. Here we have operations from Fiber and operations from REPL, which can be confusing, but we have what we have. Perform operation, get message, and we need to match the result. Do we have ICE9 match? Okay, we have ICE9 match. We either get finished like this. I always forget the syntax of pattern matching. Finished, yes. Okay, that's right. It's either finished do we need to check if our channel contains something? And other case, will be a response. And we will need to send it to the client. Okay, the response. So here we decouple the socket from our asynchronous code. Our asynchronous code don't know anything about the socket, and it will be using channel for communicating between fibers. If finished, just return OK. That's finished processing request. Okay, we made our code much more complex without getting any benefits so far, but we will get them later, I guess. Run operation sessions, channel finished, and operation will get session channel finished. Of course, here message to the channel. Operation sessions channel finished input. Good. Now we need to refactor all the operations. Let's see. Channel finished. Signal. Signal condition finished. Channel finished. And we need put message channel. Okay. Here we do the same. Signal condition. Channel finished. Put message channel like this. A little bit of extra work. Completion. Channel finished. Put message channel signal. Colon OP. Channel finished. Alright. We need to put message channel. And here like this. And we have only one operation left, I guess. Sessions channel finished. Response 4. And let's see. Okay, it doesn't work. Why not? Why not? Why not? Why not? Process request spawn fiber. Blah blah blah. Oh, I see. Loop. Maybe this is a problem. No, it's not. Let's see. Wait operation. Oh, where's our clone operation? Signal condition finished. Right. Channel. Looks right. Let's go back. Perform operation get message. It's a choice operation between wrap and get operation. Looks right. Let value or I could just make a pk here. Oh, okay, we never went into this function when input. Can we just log this? Input. What else we have? Input op clone. Right. And we even write it somewhere else. Somewhere here, I guess. We execute run operation. Oh, I see. I see. The result. We don't need the result. The run operation should be spawned in fiber. Spawn fiber lambda like this. Okay, now it's much better. Now it fails, probably it will be operations. Okay, now we have a wrong number of arguments to channel. Get operation channel. Looks right, looks right. Oh, oh. Get OP. Get OP. signal condition of course. Okay, we refactored it. Interesting where we get this finished. Oh, okay, I know where we get it. We get it in pk call. Very good, very nice. Now you see we get eval call, and after that we get interrupt before the evaluation completed. And first response is here, second response is here. Good. Now let's commit the changes. Server add channel and finished condition to operations. The last piece to actually plug the correct evaluation implementation. Let's see, we have eval manager thunk that we need to run here. So instead of all that stuff, or maybe we need one more refactoring. Okay, I have another idea which maybe slightly improve the situation. I will need to think about it in more details. Our current refactoring is right, I would say. We need to use channels and finished condition, very likely. The only difference here will be that when we use a run operation, we can obtain the session ID and get some information about current status of the session. Is it evaluating something or not? And if there is a fiber processing the request for the session, and pass the message to this fiber instead. So the architecture will be a little more elegant here. This way we will have a stateful actor which contains all needed information inside itself. And if we get evaluation request, we do something. If evaluation already in the process, maybe we will need to queue the another evaluation request. Or maybe we will do it somehow differently. Okay, I need a fresh mind to design it better. For now, we introduced fibers and asynchronous processing to the REPL server. Now we need to think a little bit more about session management and how to do it better. And after that we will be able to connect eval manager to our REPL server, and we will get a minimalistic REPL implementation for guile which supports interruption. And it will be a huge achievement. After that we will be able to use any REPL client with it, at least some of the REPL clients, and also we will be able to build a new REPL clients, maybe specifically for guile. Okay, I think that we will finish today here, and we'll continue our work later this week, and later next week, and next week after next week. And so, until we get a cool, working, asynchronous, and reliable REPL and IDE for scheme. Okay, thank you very much for your attention. I hope it was useful for you. Contact me via Mastodon, IRC, or email, and I will see you in a bit. Bye.